Yeah, Poisson, you have exponential, and the only continuous distribution which really wanted to, well, I lie. The main continuous distribution I just wanted to know is the normal, because exponential is also a continuous distribution. Yeah? So, but the normal is the main one she does wait to know. And question 21 and 22 are based on the normal distribution. It has questions on the exponential distribution, which I'll go through, but that kind of rare. The main one, the Poisson, and the binomial, these are discrete. Remember, discrete. So if Miss asked you to do PDF, sketch or PDF or anything, it's discrete. Same idea. That everything will be the probability x is equal to x. So everything you learn is the same thing. You just plot in the PDF or the CDF for it. The exponential, these are continuous. Yeah, so these is continuous. So you add integrate. So from that you could just know what you have to do. Continuous, you have to do some type of integration. For discrete, is some type of addition. Okay, you just add for discrete and integrate for continuous. Because the x could be more than, less than, equal to, more than. There's a range. But anyway, so I have this little document here that's a run through the distributions. I'm not doing it, but just for you to get accustomed with how the wording is. The wording simple once you know what you're looking for. Because it's normally be worded in the same way, depending on what distribution you have to use. So I think I went through this with you last week, but kind of rushed it down. So I'll go through it again, right? So remember, for binomial, you're doing something n times, and you have x successes. Yeah, so you're doing some over and over, and you want to know the amount of times you'll be successful. The second one is the Poisson. So with this, you have successes, or you can say x successes, but it is in terms of time and space. So they'll give you a specified period or space in terms of a specific area or something. So they will tell you where's the probability of getting 5 every 10 minutes or something like that. So we'll have a specified time or space interval in it. So the main word for this is interval. There's a cool word I could remember to know if it's possible or not. Right, so these two are the main ones that she'll normally bring. So you don't have to worry about anything else. We'll see. Right? So if I read this one, it kinda eliminates the ones that you know is not. So the first thing you have to know is what type of distribution it is. Sorry, random variable it is. What is discrete or continuous? And you should know from reading the question whether discrete, what type of values it could take. From that you will know if it's discrete or continuous. So a student takes multiple choice quizzes with 20 questions each, okay, where each question has 5 possible answers and only one correct answer. Okay, so there's where the money sentence is. So they said, what is the probability that the student answers exactly 15 questions correctly if they are guessing on the questions? So they want to know, I have 20 questions in the exam, and I want to know what's the probability of me getting 15 of the 20 correct. So that literally falls straight down the truth of binomial. 20 questions is not time or space. Yeah, so you know it cannot be possible for sure. Alright, so this have to be a binomial distribution. So anytime you have that, the first thing you always do is write the special distribution you're using. So in this case, x follows a binomial distribution, and the parameters are n and p, where p is the probability of a success, and n is the total amount of trials. So in this case, n is 20, because the total is 20 questions. And the probability of a success will be the probability of you getting a question correct. Which, if let's say is 5 questions, only one answer correct. So the probability would just be 1 on 5. Yeah? And from there, no. So from last week, you should know the equation for the probability. So in this case, the probability x is equal to 50. So it will be n CR by P, which is 1 on 5, to the probability of x by Q, which will be 4 on 5. Remember, if P is 1 on 5, Q had to be the remainder, to the power n minus x. So, sorry, this here should be 50. Got I x. And then n minus x will be 5. Right? So a cool way to remember it is that the top here will always equal to what here. So that's why it doesn't know if you're going there. And when you plug that in a calculator, you'll get what the probability is. Right? So you have a combinatorics or combinations function in a calculator under the delete button, or you can say under the AC button if you have a Casio. So shift, and you can use the function. So it'll be 20 shift AC, like you say 20 shift and the button on it, which is the divide button, and it'll be 15. And you press equal and you'll actually get the answer. So you can do the combinations in a calculator. So I'll repeat. The combinations button is, for most people, the division button. So you can use that. So if you want, in this case, 20 C15, it'll be 20 shift divide button 15 equal, and you get the answer. So you can just do that and get the others, and you'll get the answer. Alright, so that's that. That's all that is. Alright, so that is the answer. With another question, 1 successes and n trials. Binomial. So continue. So this one, a factory tests light bulbs, and each light bulb have a 3% chance of being defective. So if this says 3%, the probability will be 0.03. We don't know if it's a success or failure yet. The tester counts how many bulbs it tests before finding a defective one. Okay, what is the probability that the tester finds the first bulb on the 10th bulb tested? This distribution is not tested for you, but the name of the distribution is geometric distribution. I will leave it at that. You're not gonna get tested on this. I don't think this on your syllabus really. Right? But it's a geometric. The first success in n trials. Okay, so this one here. So a hospital emergency room receives an average. See this word average? It has always come with a certain type of distribution. So I average at 3 emergency cases per hour. Anytime they give you an interval, it does most of the time fall in line with a specific type of distribution. So the steady probability of receiving exactly 5 in an hour is calculated. What is the probability that the emergency room receives 5 in? So this is basically possible. Because I want to know the amount of successes in a time, in a particular interval of time or space. In this case, I give you time. So this will be Poisson, straight off the bat. Alright, so X will follow a Poisson distribution, and the parameter for Poisson is lambda. Lambda is your average in the specified time. Yeah, so in this case, I said 3 per hour, so this here is lambda for you. Yeah, normally Miss will give you what lambda is. Alright, so you don't really have to stress too much about it. But in this case, lambda is 3. And the equation for the PDF for the street is e to the minus lambda by lambda x, all divided by x factorial. So in this case, the one the probability x is 5, so it'll be e to the minus 3, because that's what lambda is, by lambda x, in this case is 5, divided by 5 factorial. You have a factorial button in the calculator. So for most people, let's see where it is on mine. Oh, I have my old calculator. I should be able to have it. I think I have it. Alright, I don't want to waste time. But it have a function in the calculator that I could use factorial on. Right, I'll find it. So if you have a Casio, it should be on top of the x to the minus 1 button. So right on top of it, you should see x factorial in yellow. So Casio on top of the x minus 1, which is white. You should see x factorial in yellow. So you could use it to get factorial. So if you wanted 5 factorial, it would be 5 shift and that same button and equal. And if you get your answer. Yeah, so you can actually do the factorial in your calculator if you didn't know. Right, so reiterate is the button right on top of the x to the minus 1 button, which is the button before the sign button. Yeah, you see x factorial. Right, so that was possible. Okay. So to say a random number generator is used to select a number between 1 and 10. Each number has, see this here? Each number has an equal chance of being selected. It only have one distribution where that holds. Yeah? It only have one distribution. And that is a uniform distribution. Yeah? And you'd rather go any further than that. The probability of the number 7 being selected will just be 1 on n, which in this case is 1 on 10. They're not going to change because it's a rectangle. So it's a bad rectangle. Yeah, so from 1 to 10, the probability of everything in between is constant. So it's not going to change at all. It's uniform. So the probability of getting the number 7 is still 1 on 10. Each number has an equal chance of being selected. Only one distribution where that holds. Alright, so we'll try this one as our last one, and then we'll continue. So, a survey finds that 60% of people prefer coffee over tea. Okay, you want to know the probability that exactly 6 out of 10 randomly selected people prefer coffee. What is the probability that exactly 6 out of the 10 people in the survey prefer coffee? So, number is Yeah, the two options you have really is that once X successes and N trials, or N could be a subset or something, like in this case, or it could be the one to average amount of occurrences in a specified interval of time and space. So now again, no interval of time and space here. Yeah, so in this case, it's a binomial distribution where N is 10 and P, they give it on top there. In this case, will be 0.6. So X follows a binomial distribution of parameters 10 and 0.6. So in this case, I want the probability X is equal to 6. So it'll be N CR P to the power of X by Q. So if it's 0.6, Q is 0.4 to the power N minus X, which is 4. 6 plus 4 is 10. So the relationship holds. And you plug that in a calculator and you get your answer. Right, so that is the intro. So I've got a helpful. So to recap, don't know how much I got it. Binomial, they have X successes and N trials. Have no interval of time and space there. Poisson is the average in a specified interval of time and space. Uniform, just as the sentence states, is the same probability for everything. Okay, uniform. Yeah, well, the fourth one is the normal distribution, which that is not discrete, so that's a totally different ball game, right? That is specifically used for continuous random variables, like weight and mass and time and that kind of stuff. Right, and that is it. So before I jump into the tutorial questions, you all have anything to ask about this? Okay, let's go into the tutorials. Right, no problem. So I hope all you hope it was helpful, because you don't normally worded the same, and if you know how it is worded, you will automatically know what distribution to use. At that point, it's just you memorizing the equation for the, in this case, if it's discrete, the equation for the PDF, the equation for the expectation, and the variance. Okay, so let's start. So I want to do the, like, straight to the final answer. Well, I want to get through it. I'll do the question, but I'm not going to waste time punching it on my calculator, right? So y'all could do that when you're going through the video. So everybody should get the same answer. So at that point, it's probably how you place in your calculator. Alright, so let's run through this one. So from what we learned, a binary sort generates digits 1 and 0 randomly with a probability 0.6, 0.4. What is the probability that 2 1s and 3 zeros will occur in a 5-digit sequence? So they want to know, well, in this case, I never gave everybody successes. So you have to determine what your success will be. It doesn't matter what you pick, but I gave you n. Yeah, so I'll say let x be getting a 1. You can say again a 0. It doesn't really matter which one you pick. Yeah, because they never specified, but we know let x be that. So the second thing we need to know is what type of distribution it is. Yeah, so they never give me any interval of time and space. Let's give me n trials. Because the n is the 5-digit sequence. So it had to be a binomial. Yeah, just like that. Simple. So you say x follows a binomial distribution. N in this case is 5. And P is the probability of success, which we deem given a 1, which is 0.6, given in the question. Yeah? So now, you can answer the question at all. So, the probability that 2 1s, so probability x is equal to 2. So that would be n C R P to the power of x by Q to the power of n minus x, which is true. Then you plug that in a calculator and you get the answer. So that is A. So B now, the probability that at least 3 ones, right? So probability x is more than or equal to 3. So there are multiple ways you could do this, but the easier way to do it is just to carve out everything less than 3. So you could say, because if you draw a line, so this is 0, 1, 2, 3, 4, 5, right? So the question asks is the probability x is more than or equal to 3, which is this interval here. So since it's discrete, you will have to do the equation for 3, 4, and 5. Yeah? But in this case now, the part that you don't want is the one in black. The sum of the probabilities adding up to 1. So you can say this is 1 subtract what you don't want, which is the probability of x being less than or equal to 2. Remember, if it's more than or equal to 3, it's starting at 3 and it's discrete. So I have no values in between here. Remember, it's discrete. So the next, if they say more than or equal to 3, the 3 already included in the interval that you want. So the pieces that you don't want to be 2 and 1. Yeah? Or and 0. I can do it for 0. But you should do it for 0. Yeah? So in this case, it will be 1 subtract. We have to subtract 2. So it will be n C2 by P to the power of, well, we did on top here, so that kind of help you with it. By Q n minus x plus n CR P to the power of x by Q to the power of n 5 minus x, which is 1. And then plus 5C0 P to the power of x by Q to the power of n minus x, which is 5. So in this case it's 2, 1, and 0. And once you do 1 minus that, you'll get what I want, right? And that is it. So 1 minus what you don't want, which is the black. So in this case, carve out the black, you get the red. And that is it. If you wanted to, you could do 3 plus 4 plus 5 and get the same answer. Because in this question, there's a little bit of numbers. But as the amount of values you have increases, your efficiency will decrease. So you're not going to sit down and do that for 1000 values. So in this case, it'll be easy. Because look at the same amount that you do. But the idea is when you're doing these questions, and you could use it for the other questions that could come on the exam, is you could always use 1 minus the probability of what you do not want. Okay, if you subtract what you don't want from what you have, you're going to end up with what you want. Right, any questions on this one? Right, so something to pay attention to is at least, at most, less than, more than, and then they could say for this one, or equal to, or equal to. So at least, so that means is more than or equal to. At most is less than or equal to. Less than, we know less than is less than. More than is more than. So more than or equal to, less than or equal to, more than or equal to. Why these signs important? If they say equal to, so if they say probability x is more than or equal to 4, it's starting at 4. But discrete. Continuous, it really matter because it's one continuous line. Right? If they say probability x is more than 4, this is the equivalent of the probability x is more than or equal to 5. So you have to start one more, or if it's less than, is one less. So you have to be careful with the intervals. Right. So a noisy transmission channel has a per digit error of this. Calculate the probability that more than one error in 10 received digits. So they want to know the amount of successes in n trials, because it's a fixed interval. Well, fixed amount of trials. That is not interval, it's fixed. So they mix up the terminologies. So, okay, there you go. So it follows a binomial. Successes in n trials, so n is 10, and the probability of success, which is p, is 0.01. So in this case, the probability, they want x to be more than 1. So if I want more than 1, so 1 here, so basically I want all this, straight up to 10. So just like I told you, so 0 here, I could just subtract what I don't want. But they said more than 1. So therefore, 1 will be included in the interval that I do not want. So this is equivalent to saying a probability x is more than or equal to 2. Yeah, because in the interval itself, more than 1 can start at 2. Remember, it's discrete. There are no values in between here. They jump straight to 2. So in this case, I get as 1 minus what I do want. So it will be the probability x is 0 plus the probability x is 1. So that will be 1 minus NCR P to the power of x, which in this case is 0, by Q to n minus x, plus NCR P to the power of x by Q to the power of n minus x, which is 10 minus 1, which is 9. And you plug that in your calculator, and you get answer. So that was that. Any questions on it? Okay, next. Okay, so this one I kinda give it away, but if I wasn't to give you this or this, a number of telephone calls arriving at a switchboard during a 10-minute period is known. Yeah? So they gave you something with respect to time or space, an interval of time or space, and it's fixed. So this have to be possible. Okay, I have no trials here. 10 minutes is not a trial. Yeah? So it's possible. But in this question, she cannot sell it out because she gave you the distribution and the parameters of it. So she cannot help you out. So but in this case, it's just a plug and play. So x follows a Poisson distribution and the parameter is lambda, which is 2, because she gave it already. So then the first thing I want is the probability that more than 3 calls arrive. So x is more than 3. So it are not equal to or anything. So okay. So in this case, more than 3 will start at 4. So draw a line, I carve out what I do once. So 0, 4, I don't know where it ended, I don't really care, because I just carve out what I do once. So 1, 2, 3, wanted go on. Because 3 will be part of the interval that I do once, because I never said equal to. So more than 3 can start at 4. So this are the goal. And the part in green is what I want. So this will just be 1 minus what I don't want, which is the probability x is 0 plus the probability x. 1 probability x is 2 plus the probability x is equal to 3. So that will be 1 minus, so remember the equation for the PDF is e to the minus lambda by lambda x divided by x factorial. 0 factorial is 1, right? Plus, so it will be e to the minus x, so minus lambda, sorry, by lambda x divided by x factorial plus e to the minus lambda, but in this case is 2, so by lambda 2, and 2 factorial plus e to the minus lambda by lambda x, in this case is 3, by 3 factorial. Now when you put in a calculator, you get your answer. And then the last one, find the probability that no calls will arrive, which kind of weird. So the one, the probability x is equal to 0. So it will just be e to the minus lambda by lambda x divided by 0 factorial, which will just be e to the minus 2. So 2 to the power 0 is 1 and 0 factorial is 1. Yeah, so yeah, I guess that's all that. And that's it. That's all it is. This is part B. And it's part A. Any questions on that? Okay, nice. So the concept is 1 minus where you don't want. Carving out where you don't want. They're kind of inefficient to just add up everything. It will waste time. Okay, let's continue. Okay. So this is a exponential distribution. So assume that a length of a phone call in minutes is an exponential random variable with lambda is 1 on 10. Okay, so x follows an exponential distribution of parameter 1 on 10. Okay, if someone arrives at a phone booth just before you arrive, find the probability that you will have to wait less than 5, between 5 and 10. The trick to know if something is exponential is like Poisson, but instead you're manipulating the interval. That's why I remember it. Just in case she don't give you exponential in this case. How you will know is if it's something like a Poisson, but the change in the interval of time or space is exponential. Like best way I could put it without getting too complicated. So you notice in this case the change in the interval of time or space exponential. Remember there's a continuous distribution. Alright? So let me go. So part A, probability that's less than 5. So this here, remember, less than 5 starting at 4. So it'll be x is less than or equal to 4. Right, so there are some nice equations that you could memorize for exponential distributions. So, alright, it's on this side in black, and I could probably write it. So, first thing, the probability x is less than or equal to e is 1 minus e to the minus lambda x. The second one is the probability x is more than e, which will just be e to the minus lambda x. Yeah, so kind of. So in this case, the one is probably less than or equal to 4, which is straight from here. So that'll be 1 minus e to the minus lambda, which is 1 and 10, by x, which is 4. So that's that. So I think in this case, this law here, it doesn't hold fully. But the reason why is for continuous. So in this case, the exponential normally look like this, right? That's how it was. But the problem with seeing this here, alright, is for a reason, right? Because we have to see it. This thinking here is wrong. The reason why is that if you have 5 here and you have 4 here, remember for discrete it won't have any values in between here. But for continuous, there are values in between here. So you can't really say this in continuous random variables. So don't get confused, I'll tell you. They are both the same thing. Yeah, it's literally the same thing. So if the law say less than or equal to A, and the question asks what is the probability x is less than A, is the same equation. Because it continues, it will be the same exact thing. So if they say in this case the probability x is more than A, that's going to be the same thing as the probability x being more than or equal to A. Because it's same thing, equivalent. Yeah, so don't ever do this for continuous random variables or for continuous distributions. This only holds for discrete, because it only exists at discrete points. So be careful. So you can erase all this and just write probability of x less, yeah, just equal to less than or equal to 5. And it'll be the exact same thing. So this 4 here will just be 5. Okay, if you put 4 there, you'll get the question wrong. Because you treat any distribution like if it's discrete. Yeah, so be very careful with it. So this will be 1 minus e to the minus 2. Right? So that's a recap for this for continuous. X being more than a is basically the same as x more than or equal to a. This being less than a could just be the same as x being less than or equal to a. And the same vice versa. This is the lowest. So it really matters which one you choose. Less than equal to, same equation. Only for continuous. Right? A lot of people was asking me about that. You could only use that for continuous. For discrete, if they say less than equal to 5, or say less than 5 in this case, you had to go less than equal to 4. Next. So on the next part B. So between 5 and 10. So the one's the probability x being less than 10 and more than 5, which could be written as less than or equal to this gets slapped equal to. depending on how you want to manipulate it to use the equations. So what I like to do is write a line. So there's 10, 0. So less than 10 will be everything here. And then more than 5 will be everything here. So the piece that I don't want is less than 5 or less than or equal to 5 because it's continuous. So I could just subtract this from 10. So if you say the probability x being less than or equal to 10, which is everything in red, straight down, subtract the probability x being less than or equal to 5. That will work. Okay, if you subtract the orange, or say the black from the red, you will get the piece that I want. So less than or equal to 10, you have an equation for that. So it'll be 1 minus e to the lambda minus lambda x, which in this case is 10, subtract, and you already get the answer for this one on top. So you cannot get through. Analyze it. Right. That was it. So takeaways for continuous is nice. For the inequalities that overlap a lot. Right. For discrete it overlap. The jump. Right. Basically for this question. So any questions on this one? Alright. Nice. Okay, so this one, same idea. Yeah, that's how they use it differently. So all the manufacturing devices and machines fail to work, blah blah blah. Suppose that the failure rate is constant and the time to failure in ovens is exponential. The parameter lambda, okay? X follows the exponential distribution parameter lambda, okay? Part A. Change color. Measurements show that the probability that the time to failure for a computer chip is given class, sorry, in a given class, exceeds 10 to the power of 4, which is probability x being more than 10 to the 4, is equal to e to the minus 1. Calculate the value of lambda. Okay. So we just learned our equation for when the probability x is more than e. So if you scroll back up, so when it's more than is just e to the minus lambda x, right here. So therefore, in this case, e to the minus lambda by 10 to the 4 is equal to e to the minus 1. Rules are bases. Bases are the same, so for equal base, minus lambda by 10 to the 4 is equal to minus 1. Negative will cancel. So lambda will equal to 1 on 10 to the 4. So that's all that was. Part B now. Use any value for lambda determined before. Calculate the time to x0 such that the probability that the time to failure is less than it. So the probability x being less than 0.05. Right. So this case will be less than x0 and that is equal to 0. But I would have said in the question, besides using the parameter for lambda determined before, calculate the time x0 such that the probability that the time to failure is less than x0 is this. So that is this here. So we have an equation for this that I can use. which goes back on top. So less than basically the same number. So you can use that equation by 1 minus e to the lambda x. So this here is 1 minus e to the minus lambda, in this case x0, and that is equal to 0.05. We know what lambda is. And that is equal to 0.05. So you're trying to transpose, so you calculate your 1. So 0.05 subtract 0.1, negative 0, so negative 0.95, and the negatives will cancel. So you end up with e to the minus 1 10 to the power of 4 x0, which is equal to 0.95. So you're trying to get rid of the exponential in this case, which will be a problem for the future. So in this case, what you will have to do is long both sides. Because long will get rid of e. But ln e, 1. It's cancelled. So this will cancel. So you're going to put the toughness. And this will stay as ln of 0.95. Beautiful. So ln of 0.95 is you place in the calculator, you get negative 0.051. Negatives will cancel. Multiply both sides by 10 to the power of 4. Because we're trying to get x0 by itself. So you multiply by 10 to the power of 4. And you get 512.93. I think it was years. And that was fun. That's what it was. Any questions on it? Oh, nice. No problem. So that was that. Exponential. So all in all, the inequalities overlap, which is the beauty of continuous, which makes it kind of easy. But once you remember, you can really make it overlap with others. But anyway, so this is our last piece. Alright, so this will be the last question for the day. This will have the HC coupon, and that should take you to practice enough for the rest of the tutorial. So there's normal distributions. So they said our production line manufactures 1000 ohm resistors that have a 10% tolerance. Let X denote the resistance of the resistor, okay? Assuming that X is a normal random variable with a mean of that and a variance of this. Find the probability that the resistor picked at random region. So the first thing they said, X follows a normal distribution, and the parameters for normal distribution are mu and sigma squared, which is a variance, right? So there's a mean and there's a variance. Those are your parameters for your normal distribution, right? So in this case, X follows a normal distribution. A mean is 1000 and sigma squared is this. Gotta give it any question. Okay? So the second thing you have to do is sketch the PDF. So the normal distribution is a bell-shaped curve centered about your mean value, which in this case is 1000. So there's a bell shape. So this is positive infinity minus infinity. It's centered about your mean, so therefore it's symmetrical about your mean. Alright? So there's a PDF. There's a PDF of a normal distribution. right? And the equation fits. So f of x is equal to 1 on the square roots of 2 pi sigma squared by the integral, you can say e to the of e. I think it's about the integral. So that's be e to the minus x minus mu squared divided by 2 sigma squared. The reason why I took out the integral is that they never ask for the problem any interval in between points. So this is just the raw equation for the PDF for normal distribution. Yeah, so that's just our side. Okay, I use that in 21 and 22 over and over. Right? Okay, so our question is said that it has a 10% tolerance. So remember, our resistor values does work. They'll give you a tolerance which is above and below the stated value. If it's above that or below it, it will be rejected. So we had to find what the upper bound is and the lower bound is. So 10% of 1,000 is 100. So therefore, the highest it could go is 1,100 and the lowest it could go is 900. Yeah, so say rejection region will be this here and this here. Yeah, so the rejection region. Anything above or below 900 will be rejected. So we continue. We have to set up something. So that's our side notes. I'm going to go into that and I'll show you the proof. So you have two types of errors. So centered at 0. So your first one, this is if, which is just an error function. So the error function, the equation for it is 2 on pi by the integral from 0 to x of e to the minus t squared dt. And it is symmetrical. That is where I got the 2 from. Yeah, because it will be here and here. Yeah, so that's where the 2 came from. Alright, so that is the error function. And the other region is here, which by default will be here also. And this will be a of C, which is a complementary error function. Yeah, and the equation for that, so your earth should have run from x to infinity, which is the other piece of the earth. So earth C of x will be 2 on pi, as I before. The integral, but now the integral going to go from x to infinity, and it's still e to the minus t squared dt. So these two equations here, very important. And all you have to remember is earth is go from 0 up to x value, and then earth C is go from x to infinity. Right, so all in all, earth C of x is just 1 minus earth of x. Because think about it, the total area under the graph is still 1, because it's still probability. So if you subtract earth, which is orange, from the total area, you'll just end up with this piece here, which is basically earth C of x. So you need to know these two equations here by heart, because you will ask your questions on it, which is the proof again. Right, so So back to what we wanted to do. I'll send you all the PDF with it, so you will have it. Alright, so the one to then this question. Find the probability that the resistor picked at random will be rejected. So you already show what the rejection region is. So if you look at the rejection region here, or what we did just now, this here will be OOF C. Not OOF, but OOF is this region here. You cannot treat 1000 as 0, it just centered as 0. But 0 is basically whatever the denominator, or whatever the mean centered about. So 0 and 1000 is the same plot. The drawing of it will be the same. So don't overthink it. So in this case, 1000 to 1100 will be what if x is. And then in this case, 1100 to infinity will be what if c is. So all of these zero confusing. They're just whatever it's centered about. Alright, so I do that with our space. So what I want, so the probability of a rejection is, so you have to integrate the PDF. Yeah? But remember, when you want probabilities, you have to integrate the PDF. And remember the PDF, which is the f of x thing I told you just now, is 1 on the square root of 2 pi sigma squared, square root over all of that, by e to the minus x minus mu squared on 2 sigma squared, right? So if I want probability, I have to integrate the PDF, because remember, probability for continuous is the area under the graph. I need to integrate the graph to get the area, which will give me the probability. That is why I have to call the integration. I'm sorry I'm not given this, but I was wrong. So this is the PDF. I want probability, I have to integrate the PDF. So in this case, the probability of rejection will be the integral of f of x dx, and in this case is oopsie, so it'll be from 1100 to infinity. You don't have to do it for 900 down, because remember, you can just multiply your oopsie by 2, that I what oopsie is. So you don't have to do it for both of them. Do it for one, it's symmetrical, you multiply it by 2, which you would just end up with oopsie of x, as you will see as you go through. So in this case, I run through this. Probability of r, that the one write rejection of 1 will be 1 on the square root of 2 pi sigma squared by the integral of 1100 to infinity of e to the minus x minus mu squared on 2 sigma squared dx. So that's what we have. So we know is if c. And how does if c look? 2 pi integral from x to infinity of e to the minus t squared dt. So if you compare these two things, they're not looking the same. So your goal when you're doing the proof is to get it to be in this form. That's really all you're trying to do. The proof itself is the same thing. Now they're going to change at all. Really. So once you know how to do this proof, it's the same thing. Just at that point, you just memorize the steps. So the first thing we had to do here, the first thing we could do is get this part here to look like this. That's the easiest thing to do. But once you do that, everything else just fall in line. So first thing you say, let's t squared equal to what you have. Right? Okay, I want to get rid of this piece here, but you have to keep the minus 2. So in this case, square root both sides. So t would just be x minus mu on the square root of 2 and the sigma outside in this one. Nice. So what we have to do now, we have t. Well, we need to get rid of the dx. So we need to differentiate both sides. So we get dt on this side, and on the other side, we have a set of constants. So mu is a constant. So we differentiate this, you just end up with 1 and the square root of 2 sigma dx. Because when I split this up, right, what goes up here? So it's x and the square root of 2 by that minus mu by the square root of 2 by this. So if we also differentiate this part here will get dx, or 1 by dx, 1 and root 2 sigma by dx. And this part here will go, because differential of a constant is 0. So let's say I get this piece here. Nice. So we have to make dx the subject of the formula. Remember that we want to replace. So dx will equal to square root of 2 sigma dt. Let's kind of carry this across, and you end up with the dx by itself. So this is good. So far, we know what we're doing with t squared. Right, this here was done to get differentiated. So we know what t squared is, you know what dx is. The last thing that we need to get rid of is the bounds here, or your limits. Remember, these limits are with respect to x. So since you change what you differentiate with respect to, you have to change your limits. So very simple, that's why we got this equation here. So when x is equal to this, so t will equal to, plug in x, and then when x is equal to infinity, t will equal to infinity is a very big number. Subtract a comparatively small number divided by a comparatively small number, which will give you back a very big number. So this whole thing here will just give you back infinity, right? So we good. So we have t squared dx and our limits. So finally, we can plug everything back into one nice equation and simplify and end this question. So the probability of rejection 1 on square root of 2 pi sigma squared by the integral, the bottom piece was 1100 minus mu on the square root of 2 sigma, and the top was infinity. E, remember we place the big piece here with minus, so it'll be minus t squared. And dx, we replace dx with square root of 2 sigma dt. So this piece here, we kind of rewrite it in a different way. So stop the cancel. So I get the square root of 2 square root of pi sigma. Remember before it was the square root of 2 pi sigma squared. So when you remove the sigma, remove the square root from everything, you'll just end up with the square root on each. So clearly you're seeing here that this will cancel with this, and this will cancel with this. Yeah, so you end up with the probability R is 1 on square root of pi by e. Yeah, sorry. Integral this on infinity e to the minus t squared root 2 sigma. Sorry, I can't say dt. So you have that, and a dt kind of form. So you're kind of done. But with respect to this question, this piece here is just 1/2 of your ones. Remember, you have this other piece here. So let's just multiply this by 2. So that, when you multiply that by 2, you end up with a c of x, right? Which will just be 2 root pi, same thing as before. You're looking exactly a similar thing. And just to round it off, just say the probability of r is equal to c, and x in this case will be your lower limit. Yeah, and let me see it. Not 2. So start at 2 pi same square. And that is it for loop c. So in this case is just loop c. Some questions will just be half loop c, which means you just care about one half. Some questions you care about both. Okay, in this case, fire resistor value you care about above and below. So that is why it will be just flat out loop c of x. And that is it. That is it. So that's a recap the proof. Integrate a PDF. So the three things you had to change is t squared, t, which is your differential, where you differentiate with respect to, integrate with respect to, and your limits. And you just plug back everything. Normally your sigma, no normal. Your sigma and your root 2 supposed to cancel with what down here. And from there, this right now is just half of loop c of x. Yeah, because that's what half is. You want. When you multiply by 2, you just end up with loop c of x. Let us aside. So let's erase that big ugly circle of pyramid. Break a little bit. Yeah, and that's it.